Okay, students, we're going to continue on with a concept called molarity, and I believe you've seen this before. Molarity is abbreviated with a capital M, and it is a measurement of how concentrated a solution is. That is, how much of a dissolved solute is in the solution per unit of volume of the solution. And specifically, the volume of solution that we're talking about usually is per liter. The more concentrated a solution in is, the higher its molarity. So you could have a high molar solution, high concentrated solution, or a low molarity of solution. Molarity is mathematically defined by a relationship here, and it's capital M molarity equals the number of moles of solute that are dissolved per number of liters of solution. And once you plug in the number of moles of solute in the numerator and the number of liters of solution in the denominator, and then you resolve that fraction, you will end up having a number of moles per 1 liter. And that's what molarity is. It is the number of moles per liter. So another way of saying it is moles per liter. So note that molarity, when we call it a moles per liter, the number of moles of solute per liter of solution, note that it is actually a conversion factor. It is written as a factor, and it converts between two units and substances. So which two units of measurement does molarity convert between? It's the number of moles, and it will convert back and forth to liters of solution. So specific moles of solute to liters of solution and back and forth. So if you have liters of the solution and you want to convert to moles, you can use the molarity. If you have the number of moles of solute and you want the liters of solution, again, you can use the molarity as a conversion factor. Well, before we use molarity as a conversion factor, we're just going to use it as an equation here, as an algebraic equation, M equals moles per liter. And so we're going to do some simple calculations. First of all, we're going to calculate the molarity. Remember molarity, capital M, of a solution, and we're given 11 grams of this solute, sodium chloride, and this volume of total aqueous solution. So if I start to set this up, my molarity, which is what I'm solving for, is the number of moles of solute divided by the number of liters of solution. So I'm going to have a number to plug in the numerator and a number to plug in the denominator. And I'm not given either of these numbers directly in the problem. But you can see that I'm given grams of solute. And so I can do a little side calculation to convert from grams of solute to moles of solute. And then I can plug that in the numerator. And I'm also given the volume of the solution in milliliters. So I can do another side calculation to convert from milliliters to liters, and then plug that in the denominator. So what I'm going to do here is I'm going to leave space for when I have these numbers so that I can then plug them in here and then get my answer. And my answer will be molarity is the unit of measurement. So that's going to be my answer right there. But I need numbers to plug in for the numerator and denominator, and then I can resolve them to get my answer. So in order to get the numbers that I need to plug in the numerator and denominator, I need to do some side math, some side calculations over here. And so that's what I'm going to do now. I'm going to convert these grams of solute to moles of solute to plug in the numerator. So 11 grams of NaCl. And I'm going to use a molar mass conversion grams of NaCl to moles of NaCl. Notice that I am abbreviating moles as MOL and not as capital M, because capital M is not the abbreviation for moles, it's molarity. So be very careful about that. And that's going to give me the moles of my solute, and when I get that, I'm going to be able to plug it in here in the numerator. Similarly for the denominator, and these are all separate, for the denominator, I need liters of solution. I've got 250 milliliters. And so I'm going to do a dimensional analysis to convert between milliliters and liters. And that's going to give me liters of solution. Okay? And when I have that answer, I can plug it in the denominator. So, molar mass conversions are always per 1 mole. So if I add up my sodium chloride, and I get 58.443, is my molar mass, my grams per mole. Now if I run this calculation, the 11 grams divided by the 58.443, I get the answer, and I'm going to have to round it to 2 sig figs because of that 11 right there, from 0.1182, that rounds to 0.19 moles of the solute. And now I have the number that I'm going to be able to plug in for my moles of the solute. And that's for NaCl. Down here, converting from milliliters to liters, I know that I have 1,000 milliliters for every 1 liter. And so the answer here is 0.250 liters, and that's my denominator. Liters of solution. Okay, now I take my numerator divided by my denominator, and I get 0.76. And that is the concentration, the molarity of a solution with 11 grams of solute, sodium chloride, dissolved in 250 milliliters of solution. So there's my answer right there. I'm going to put a nice circle around it. Now what does this mean? So I am given a molarity here. I'm given a concentration. And this concentration means that I have 0.76 moles of solute per liter of solution. So this right here, by being given this molarity, I am given a conversion factor. I'm given this many moles per 1 liter. So as we move forward, I want you to train your brain so that every time you see molarity, you recognize that you're being given a conversion factor, because it may come in handy to be able to convert between moles of solute to liters of solution. So we're going to move on here. We're going to use the same equation. Molarity equals moles of solute divided by liters of solution. And now we're going to rearrange the equation to solve for one of these other variables. Now it says calculate the number of moles of this KBr, that is a solute dissolved, if you have that volume of solution. And it is telling us that that is the molarity. So if I have my molarity equation here, number of moles of solute over number of liters of solution. And now we're going to be solving for the moles of the KBr. So what I would like for you to do is I would like for you to pause the video, see if you can rearrange this algebraic equation to solve for the number of moles of KBr, solute, then plug in all the other numbers and get the correct answer for this problem. Go ahead and pause the video now and see if you can do that. All right, coming back from pausing the video, I have my molarity equation here, the general form of the equation. I'm first going to rearrange it algebraically to solve for the number of moles of solute. And since the moles of solute is already in the numerator, all I have to do is multiply both sides by this denominator to get it alone by itself. So that basically means I'm going to bring this number of liters of solution over here. So it's the number of liters of solution times the molarity of the solution equals the number of moles of the solute. Because that's what we're looking for, the number of moles of that solute. So now I have my equation set up to solve for the thing that I'm looking for, and now all I have to do is to plug in values. Well, I don't have liters of solution. They've given me 45 milliliters, so let's do that conversion. 45 milliliters, 1,000 milliliters per 1 liter equals 0.045 liters solution. So I know how many liters of solution. I can plug that in here. And they've given me the molarity, which is 0.012 molar. And there we go. We've plugged in our numbers with the correct units, the molarity and the liters. And now all we have to do is to do the math. And so we have 0.045 liters times 0.012 molar equals 0.00054. 2 sig figs, 0.00054. And what are the units in substance? It's moles, isn't it? It's moles, and specifically of KBr, that were dissolved in those 45 milliliters. So there we go. And the hint was here. If molarity equals moles of solute divided by liters of solution, then we needed to rearrange the molarity equation to solve for moles of solute, and that's exactly what we did. So we can use the basic molarity equation, and we can solve for molarity, or moles of solute, or liters of solution, just by treating it as an algebraic equation and rearranging it to solve for the unknown.